Hello everyone, welcome back to Calculus BC. We're in lesson number 38 where we're going to be talking about polar graphs. For this lesson, we will not be doing very much calculus at all. I want this lesson to kind of serve as just a review on how to convert from polar to rectangular and how to graph polar functions. And then in lesson number 39, we're actually going to really get into the calculus part of polar. So first thing we're going to do is some simple conversions. So my whole thing I wanted to show you guys right here is that if we were to look at quote unquote the origin of a Cartesian or rectangular, then we would call it the pole, right? The pole is going to be in the center. And the most important thing is that the x-axis is our polar axis. So everything comes from that. This is also very similar if you guys had like an xy coordinate plane. This would be where our, even look at the unit circle, right? This would be where 0 is. This is the theta of 0. And so this is our r. And what I like about this is that these are the four equations that you have to know to convert from rectangular, which you guys are very used to, x comma y, to polar. And polar is going to be in the terms of the radius and then the theta that gets us there. So what do we do? How do we get these equations? Because you know them all. You actually know them all, even if you don't know that you know them all. So if we go back to good old geometry for 1 second, and I'm going to go ahead and call this theta. And I'm going to call this distance y, because again, it's all about our y, and this is going to be called our r. And I asked you guys to use good old SOHCAHTOA, right? Good old SOHCAHTOA. So SOHCAHTOA, the sine of our angle, is the opposite side, which again is our y, our direction of y, all over our hypotenuse. And if I were to cross multiply, I would get that y is equal to r sine of theta. And so this is where this equation comes from. It is SOHCAHTOA. Y is equal to our radius times the sine of our theta. Well, similarly, if I were to go and ask you guys to find the cosine, and so let's go ahead and add now our x value here, and we want to find the cosine of theta. Well, that's going to be the adjacent side. The adjacent side, again, we're going to call this x because of our x, and of course we're assuming this is a right triangle. So we're going to have x, which is our adjacent side, over our hypotenuse. We're going to cross multiply again, and we're going to get x is equal to r cosine of theta. So these two equations are just rewriting what you know from SOHCAHTOA. Tangent of theta is the opposite side over the adjacent side. We don't have to rewrite here. We're given that right there. So these three equations come from SOHCAHTOA, right? So let's look at this one. Well, what is this? Well, Pythagorean theorem. Pythagorean theorem tells us that x squared plus y squared, which these are the legs of the right triangle, give you r squared. So this guy comes from Pythagorean theorem. So like I said, ladies and gentlemen, you actually know all of these equations based on basic geometry. So now let's use these equations to talk about how to solve these particular problems that you see here. So in this first video, I'm going to just talk about these four pretty straightforward questions. Again, just a refresher for your polar knowledge. So point P has coordinates of 3 pi over 6. Well, you can clearly see that this is a theta, and it also says it's polar. So we know that in this particular example, r is going to be equal to 3, and that theta is going to be equal to pi over 6. It's going to ask us to find its rectangular coordinates. We want to know what the x comma y is. So when you're trying to find polar to rectangular, so you're going polar to rectangular, then you're going to use these two equations right here. Because you're given the r and you're given the theta. So polar to rectangular, you're going to use the x is equal to r cosine of theta, and then y is equal to r sine of theta. So that's our little kind of background knowledge for that. And so let's just actually plug in what we know. Well, x is equal to, our radius is 3, our cosine, and again, we also know that cosine is always going to be our x, right? Pi over 6. So we know that 3 cosine of pi over 6 is the square root of 3 over 2. So we know that the x coordinate is going to be 3 square roots of 3 over 2. And then similarly, let's go ahead and change the color here. We get y is equal to r sine of theta. Well, we get again that 3 is our radius. We're going to go ahead and write the sine of pi over 6. We know that y equals 3 sine of pi over 6 is going to be 1/2. So we know that the y-coordinate is going to be 3/2. All right, so that is how you go from polar to rectangular. Well, if we go on the next part of the question, it's going to say, what is, given we have a rectangular coordinate, find 3 sets of polars. So again, this is going to take us back. But let's first of all find the first one. Let's use our very basic equations right here. So if we want to go from rectangular to polar, then we're going to use the equations that tangent of theta is going to give us y over x. Let's erase that and make it better for us. And you know this because, you know, what's given to you. We have our y and our x, so we can easily find theta. And then we know that r squared equals x squared plus y squared to find our r. So let's find the r first. So r is going to be equal to, so r squared is going to be equal to our x squared plus our y squared, right? So it's just going to be Pythagorean theorem. So we're going to get the r squared is going to be equal to 16 plus 16. R squared is going to be equal to 32. And so r is going to be equal to the square root of 32, which you guys know is just going to be 4 square roots of 2. All right. So most people can see special right triangles, though. If we have a leg of 4, 4, then that's supposed to be 4 square roots of 2. So our r coordinate is going to be equal to 4 square roots of 2. And then theta, we're going to use that tangent of theta is going to be equal to our y coordinate, which is -4, over our x coordinate, which is also 4. So we're going to find that tangent of theta, and I'm so sorry, that is absolutely horrible handwriting. So tangent of theta is going to be equal to -1. So tangent of theta is going to be equal to -1. So arctangent of -1 is going to be equal to, well, let's write the theta right here. So you guys know that tangent is going to, or theta is going to be equal to -pi/4, right? So tangent of pi over 4 is 1. If I'm looking at this, so if I come up here in my little picture, then I'm going to be here at -pi/4. Now, I'm going to go ahead and write the -pi/4. So this is one of our solutions. So we want to ask for a couple other sets of this exact same thing. So what we're going to do is this. I'm going to erase for you guys. Okay, so basically I wanted to erase this. And so my end goal is to be right here. I want to be right here. So we're always going to start with our polar axis right here. So our radius is still going to be 4 square roots of 2. So if I want to keep 4 square roots of 2, how else can I get from here all the way over to here? Right? So if I go -pi/4 in this direction, well, what can I do to get to this particular example right here? So how far I need to go? And that example is going to be 7pi/4. So these are the exact same thing. If our radius is positive, right, because again, this is our end goal is to be right here. So our radius is in the positive direction. We went either -pi/4 or we go a full cycle. And again, we know that 7pi/4 plus 1pi/4 is 2pi. So that is another way of doing this problem. So let's go in the other way. So let's make our radius negative. So let's make our radius go in the -4 square roots of 2 thing. So our radius ends up being a negative value. Instead of being right here, we're going to go on the side. And remember, our end game has been, and I've erased it, so I apologize. Our end game is to get to right here. We want this as our new theta. So we can go in two directions. We can actually go traveling this way, or we can travel this way. So remember, ladies and gentlemen, as we go in this direction, this is positive. This is a positive value. If we go in this direction clockwise, it's negative. So remember that if we go this way, so the top one right here, I'm going to go a full pi, right? This is a full half circle, plus an additional pi/4. So that's going to be 5pi/4, but in the negative direction. And now where I wrote 3, it's going to be 4. Let's go ahead and change that to a 4. And then I could also be -4 square roots of 2, and then go in this direction right here. And so this is going to be, if this whole thing is pi, and this is be pi/4, I have to subtract pi minus pi/4, sorry, and I'm going to get 3pi/4. And you guys can see now that all the family members are there. There's 1 pi over 4, 3 pi over 4, 5, and then 7. So that's another easy way of doing the problems with what's going on. Remember, the end game is to create the theta that we have when we initially solve our problem. So this, even though it says 3 sets, we actually found all 4 of them for this particular example. All right, so let us do the last 2 questions here. And it says a curve has an equation of 2x squared plus 3y squared equals 9 and is a rectangular. What's the equation of this in polar coordinates? Well, we already know what x is equal to, right? X is equal to r cosine of theta, and y is equal to r sine of theta. So we're just going to go ahead and substitute in. We're going to do 2. We're going to go ahead and replace this with r cosine of theta squared. We're going to have 3. We're going to replace y with r sine squared theta. And then we're going to go ahead and just have ourselves our little 9. So we're going to be left with 2r squared cosine quantity squared plus 3r squared sine quantity squared is equal to 9. So usually what they want you to do is to solve for r. I mean, that's really the idea of what we do with these problems. So we're going to pull out an r squared on the left-hand side, and we're going to be left with 2 cosine squared theta plus 3 sine squared theta is equal to 9. And then finally, r squared is going to be equal to 9 over 2 cosine squared theta plus 3 sine squared theta. And we're okay leaving our answer like this. So normally when they ask you guys to go and convert from rectangular to polar, usually they want you to have an r or an r squared equals something in terms of theta. So basically r is on one side, theta is on the other. And then the last example we're going to do in this video is to talk about the curve having r equals 3 sine of theta, and we want to find the equation in rectangular coordinates. So typically what I have students do for this problem is multiply both the left and right hand side by r. And so when we're able to do this, remember all our goal is to get the r's and the thetas gone and for us to get x and y's. Well, now we know from the equation at the top that r squared is actually simply also equal to x squared plus y squared. So that r goes away. We have a 3, and we can see that r sine of theta is actually just simply equal to y. And that is a decent example, and that is probably good. However, you guys may see that what they will do is move the 3y over, get 0, and then maybe they're going to ask you to complete the square. But like I said, if it asks for the equation in rectangular coordinates, that is totally fine. So I went ahead and just put the x squared there, plus when you're doing completing the square, remember, ladies and gentlemen, you're going to have a y squared minus 3y, and then to get the c part here, you're going to take your number, you're going to divide it by 2, and then you're going to square it. And so what you do on the left-hand side is what you're going to do on the right-hand side too. And so when able to do this, then we're going to be finally left with, and I'm completely out of room here, but let's finish this video up. It's going to be x squared. You're going to get y minus 3/2 quantity squared is equal to 9 over 4. So this is probably going to be, if they want you to really give you the equation, most likely they're going to see it in this fashion right here. Okay, ladies and gentlemen, so that was my really quick review on how to convert from polar to rectangular, rectangular to polar, and then how to go from equations in both fashions. In the next video, we're going to talk about how to graph polar functions. So I will see you guys in the next video.